My name is Vladimir Cherny. Hello, everybody. Um, I represent Modern Science Institute in Moscow, and I'll be talking about importance of magnetic anisotropic accretion and quantum phenomena for the Saturn's rings origin, formation, and stability of their particles. First of all, I would like to congratulate everybody with the new year and to wish luck everybody. And also, I would like to express my greatest thanks to the organizing committee of the 43rd COSPAR Scientific Assembly, which accepted my paper and provide for me the oral presentation. Now, I'll be talking about Saturn rings origin. I will present our new ideas. This picture made by Hubble Space Telescope, we can see the outstanding rings and still puzzled for the humanity and for scientists. After 4 NASA missions to Saturn, Pioneer 11, Voyager 1, Voyager 2, Cassini for 13 years, conclusion about origin of Saturn rings is still questionable. For instance, in presentation of the scientists Estrada, Durizan, and Cusi at American Geophysical Union meeting in New Orleans in 2017, the title of their paper был questionable after the Cassini Grand Final. Is the final consensus on ring origin and age? So rings still hold the mysteries. Gravity models of rings origin can't explain many of observed phenomena of the rings. There is still many questions about Saturn rings. What is the main phenomenon responsible for the rings origin? Why rings exist only for the planets beyond the asteroid belt? Is only gravity responsible for origin and stability of rings? What is the role of magnetic phenomena of the rings origin? Why rings exist only for the planet with magnetic field? How each ring and disk of rings were created? Why rings particles are separated and do not stick together? Why edges and gaps of the ring structure have sharp outlines? Why rings have thin periodic structure and significant flatness? Why do we see spokes in the B ring which coincide with location of anomalies of Saturn's magnetic field? Why there is a role of spectra or thermal radiation of the rings and submillimeter range? Why there is no rings for the Earth and many others. Uh, from the discovery by Galileo Galilei in 1610, Saturn rings, he was the first person who observed Saturn rings. Many people, many scientists made their contribution to the problem of Saturn rings origin. In 1655, Huygens was the first describe rings as a disk around Saturn. Then in 1675, Giovanni Cassini proved that rings and multiple smaller rings with gaps. In 1856, Maxwell, founder of electromagnetic theory, proved mathematically that rings are not solid, consist of small particles. For that, he received Adams Prize, and but he didn't believe that. He believed that rings will fall down on the Saturn. In 1947, Gerard Kuiper predicted that rings are composed of particles of ice. In 1994, Garikawa and Friedman presented their planetary ring theory based on the gravitational defragmentation of the asteroid body approaching to the Saturn and destroyed by centrifugal force and gravity force. Also, they introduced so-called gravity resonances. And they made this research for 12 satellites. Right now, we have 82 satellites already. Then, because there was no found by Cassini iron in the rings particles, in 2010, Robin Canup suggested another theory that Saturn rings formed by destruction of giant moon of Titan size. In 2004 and 2017, Cassini was orbiting Saturn and found that particles of rings consist of 93% of ice and 7% of carbon. In 2005, Cherny and Chensky published paper when they mathematically study origin of Saturn rings by using the superconductivity of the ice particles. Then in 2007, Cherney and Pospelov published paper in Astrophysics and Space Science, where they hypothetically considered from the physical point of view, the possibility of the superconductivity of ice particles. Then in 2020, this year, Cherney and Kapranov published paper in Astrophysical Journal, May 6, where they propose that Saturn rings might be result of interaction of magnetic field of Saturn with the diamagnetic particles which are orbiting Saturn within the protoplanetary cloud before appearance of magnetic field of planet. Also, there are many scientists who contributed a lot in the problem of the Saturn rings origin, like Jeff Cousy, Sebastian Charnos, Colwell, Larry Esposito, Strada, Fortov, Dougherty, Hedman, Hoffman, Krimigis, Kemp, Isamarov, Mendis, Peter Nicholson, Caroline Porca, Linda Spilker, Schmidt, Span, Matthew Tiscarena, Christopher Russell, and others. Sorry if I didn't mention someone. So many people used to work on this problem, so it's not possible to list everybody. Let's think how small a relative thickness of the rings. If compare the ratio of the thickness of a 4-page sheet to its length and the same one for the disk of rings, then thickness of the disk of rings is thousands times less. So it's difficult to imagine that such an extended and thin film with ice particles is hanging in space due to gravity only. That's why for the first time, for 400 years after Galileo discovered rings in 1610, we began studying the role of Saturn's magnetic field to know if it can contribute to the Saturn rings origin. What do we have in the area of Saturn rings location? We have gravity field of Saturn, we have which is symmetrical one, and we have axially symmetrical magnetic field with magnetic equator, and we do have a low temperature in this area. As I mentioned before, Cassini found the ring particle consists of 93% of ice. Ice is diamagnetic. It's already researched for many years, going back to former century, the 40s. And for instance, you can take a look on the paper of Sandler and Thorpe in Nature in 1962. So we need to find answer on the question about interaction of magnetic field of Saturn with the diamagnetic ice particles. How orbits of the diamagnetic ice particles of the protoplanetary cloud of Saturn's can pass into equator plane and create disk of the rings. We use theory of a small nebula suggested by Viktor Safronov from Moscow State University. And in 1972, NASA published his book, Evolution of the Protoplanetary Cloud and Formation of the Earth and Planets. And for his theory, Viktor Safronov received Cooper Prize in 1990. How we can present on the picture the process which we are going to consider. There, on the left side of the picture, we can see Saturn surrounded by protoplanetary cloud. And in this situation, there is no magnetic field yet. And all particles orbiting Saturn by chaotic orbits. Then after switching on magnetic field of Saturn, magnetic fields start to interact with the diamagnetic particle due to appearance of the force of diamagnetic expulsion. So, and gradually all the orbits of the particles gradually will go to the magnetic equator plane and create a flattening disk of rings surrounded Saturn. So this transformation of protoplanetary cloud, or we can say collapse of the protoplanetary cloud into the disk of rings after switch on of the magnetic field of Saturn. So to understand this process and to describe it, we propose theory about contribution of magnetic anisotropic accretion. After appearance of magnetic field of Saturn and switching on of the force of diamagnetic expulsion for diamagnetic ice particles, all the chaotic orbits within protoplanetary cloud start to shift to magnetic equator plane and created the ring system. At the end of movements, all ice particles become to be locked within three-dimensional magnetic well at the magnetic equator plane of Saturn. The derivative force in the particle's orbit is counterbalanced by both the centrifugal force and the force of diamagnetic expulsion. So in order to consider magnetic anisotropic accretion process, we have to show how diamagnetic particles may be responsible for the ring's genesis and stability. All diamagnetic particles in non-uniform magnetic field are known to be expelled into the weak field areas. This feature provides a minimum of the particle's potential energy in the magnetic equator plane. We study magnetization and dynamics of particles in the magnetic field of Saturn. We developed equations of collision-based motion of the particles in Saturn's magnetic field, and then we solved a particular case of those equations to demonstrate how it works in physics, their physical implication. Then we describe the dynamics of the particles in the superposition of gravitational and magnetic field of the planet. In the magnetic field, ice particles acquire magnetization and magnetic moment. They are characterizing the force of interaction with the magnetic field needed to formulate the Newtonian dynamics of the particles. And those quantities for a sole particle will be differ from those for particles congregated in the rings, when we have a lot of particles located in the ring's plane. We assume that ice particle is spherical and uniformly magnetized. Mathematical solution of magnetic anisotropic accretion problem of Saturn rings origin is based on the theory published in the Astrophysical Journal in this year, 2020, May 6, number 1, contribution of magnetism to the origin of Saturn rings by Chorny and Caprano. We solved the problem of a single magnetized sphere which is located in an external magnetic field with Maxwell equation. We obtained the Laplace equation for the magnetic potential associated with external magnetic field, which is solved via legendary polynomials. For azimuthal symmetry, the expression for magnetic potential will have this view. Then defines a scalar magnetic potential of uniformly magnetized sphere inside and outside of sphere. This is expression for inside, this expression for outside. Finally, we have magnetization and magnetic moment of diamagnetic sphere are opposing to external magnetic field, and expressions for them will be like this one for magnetization and of one particle, and this is for magnetic moment of one particle. Then we have to develop model for the disk of rings filled with the particles. Uniformly magnetized sphere in a disk-shaped structure consisting of the same sphere is a model of specially separated of dense packaging particles in the Saturn's rings. If sphere is spread in hexagonal packing with a planar particles density sigma, then expression for magnetization and magnetic moment we will receive in this view. This is a magnetization for the particles located in the rings plate. We can see in the terminator, we can see term which is responsible for the density of the planar particles in the plate. And then this is a magnetic moment. Also, there is a term which demonstrated existence of the density of particles as a sphere spread in hexagonal packing with a planar particles density sigma. So if you can compare those expressions with expressions for one particle, we can say that absolute values they are much higher than those for a Sol sphere due to the alignment of the multiple magnetic dipoles with the field. Also, force of diamagnetic expulsion into the weak field areas becomes to be stronger, and magnetic well at equator is deeper. So it means that also potential barrier for the particles to escape becomes to be higher. So it's a very stable position for the particles. Potential energy and equations of motion of diamagnetic sphere. For a spherical particle in gravitational and magnetic field of planet, in the point dipole approximation, the potential energy and force acting on the sphere, we can present in this view. This is energy, potential energy, and the first term on the right hand is represent gravity influence, and the second one is the magnetic potential energy. Force acting on the sphere is equal to the negative gradient of the potential energy. So we can present this equation for force acting, and over here also we can see the gravity term and the terms responsible for the magnetic influence of magnetic field. So equations motion is not solved analytically. We use dynamics approximation. Magnetized particles orbiting at equal distance from the center. Equation for the zenith angle looks like this. So we receive solution of this equation. It has the azimuth angle is equal half of p, which is accounts for essentially planar structure of Saturn's rings and their location in the magnetic equator plane. So finally, all the particles during the acting of the force of magnetic field of Saturn will go to magnetic equator plane in accordance with this solution. The azimuth velocity in this case is presented by this expression. So also over here we can see the term which is responsible for gravity, and the second term is responsible for magnetic fields. So we see that from both equations we can see that important role of the origin and stability of rings belongs to axially symmetrical magnetic field. And this role is increases with a smaller particle size. So we can see it from this expression over here. So at the same time, gravity force presents, and gravity force in the particle's orbit is counterbalanced by both the centrifugal force and new force of diamagnetic expulsion, which we introduce into consideration of the origin of the Saturn rings. So derivation of the potential energy formula for spherical particles in gravitational and magnetic fields has led to the equations of collision-less motion of the rings particles. Two cases or equations have been considered. With magnetic force action and without magnetic force action at the constant radial distance from the center. In the gravitational field only, solution of the equations of motion yields the ratio of angular velocity components that turns out to be extremely unlikely, which speaks against the purely gravitational approach to Saturn's rings origin. So we can say that only gravity force couldn't be could make stability for the particles for their location in the rings plane. And if the magnetic force is taken into account, the location of circular orbits of the particles in the magnetic equator plane consistently follows from the equation solution. So it means that taking into account magnetic field influence, we can say that definitely all the particles will go to magnetic equator plane where they are really located, and their location over there will be very stable. All considered above problems saying about important role of magnetic field of Saturn for the origin, construction, and stable existence of the rings. So in conclusion, we can say, for the first time, we suggested consideration of magnetic anisotropic accretion process to explain Saturn rings origin. Here is presented the magnetostatics dynamics of uniformly magnetized spheres in a spherically symmetric gravitational and axially symmetric Saturn's magnetic field. We found relationship for the magnetization and magnetic moment of both the Sol sphere and spheres placed in infinite disk-like structure of evenly distributed identical diamagnetic spheres modeling Saturn's dense rings. We determined the magnetic force acting on a diamagnetic sphere in the disk with many magnetized spheres is much stronger than that acting in a single sphere. We derive the potential energy relationship for the spherical particles in the superposition of the gravitational and magnetic fields of collision-less particles motion. We consider a special case of those equations applied to the particle in non-zero magnetic field at a constant distance from the gravitational center. As it follows from the zenith angle equation, solution in the superposition of the spherically symmetric gravitational field and axially symmetrical magnetic field, the orbits of particles finally fall on the magnetic equator plane. Thus, it explains the essentially planar structure of the rings, because all the solutions of equations saying that all particles should go to the magnetic equator plane. After appearance of magnetic field of Saturn, collisions in motion of big number of particles of protoplanetary cloud will compensate their azimuth orbital movements, and all their orbits should come to magnetic equator plane and create highly flattening compressed disk of rings with ice particles around Saturn. And that's why we mentioned before that relative thickness of the rings in comparison with the relative thickness of the A4 paper sheet is in thousands times less. Within disk, all particles of the rings will become located on the Kepler's orbits, where there is a balance of gravity, centrifugal force, and force of diamagnetic expulsion. Density gradient flow of the Saturn's magnetic field repel particles of each other, and it also cleans gaps within the ring system and forms rigid, thin structure of separated rings. So the particles repel each other because of existence of the diamagnetic force of expulsion. So two particles located nearby, they will be expelled, repel each other. That's for that reason. It also, the same situation happened with the gaps within the ring system. And that's why they will repel each other. And that's why we have formation of the rigidity structure of separated rings. And also it's related to the non-uniformity of the magnetic field, which is going by the distance from the planet. Rings filled with diamagnetic particles disturb Saturn's magnetic field lines. The magnetic field of Saturn in the plane of the disk of rings becomes significantly inhomogeneous. It's presented on this picture. So we can see the Saturn and the magnetic field lines, and then we can see the rings of the disk. So we can see that some lines can go through the disk, and because it's the particles repelling each other, and also some lines will be avoiding rings. So it's the magnetic field in the plane of rings is significantly inhomogeneous. Lines of Saturn magnetic field will strive to go through the regions with the highest magnetic permeability, and diamagnetic particles will gather in the areas with low density of magnetic field. Because magnetic field try to move out diamagnetic particles. Dense and rarefied areas of particles looks like a system of rings. You know, if we can just make a cut picture, it looks like over here we have magnetic field lines, and then over here is there is a ring 1, ring 2, and they separated by magnetic field lines, by the density of magnetic field flow. Each particle coming to the stable position at the magnetic equator plane due to minimum of their magnetic energy at this position. And this fact prevents its own move up or down of equator. It makes location of the particles in the equator plane much more stable than only due to gravity force. So only gravity force could not provide the necessary stability of the particles at the magnetic equator plane. Rings of particles prevent their own horizontal displacement due to the inhomogeneity of Saturn's magnetic field along the radius as it moves away from the planet. The same situation, by the way, happened with the stripes of iron particles around a magnet on the table when we have iron particles surrounded a magnet on the table. Thus, at the end of movements, all ice particles become to be locked within three-dimensional magnetic well at the magnetic equator plane of Saturn. Stability of the disk of rings is stronger than more diamagnetic particles in the disk of rings, and the magnetic well is deeper. So, and then the higher the potential barrier for particles to escape from the disk of rings. So taking into account magnetic force, interaction of magnetic field of Saturn with the diamagnetic particles, we can say that its magnetic field can contribute to the stability of the diamagnet of the ice particles at the rings plane. So also now we are going to dynamics of the rings particles, and we can say the dynamics of the particles in the ring B confirms our theory that ice particles have diamagnetism. We can see over here that spokes in the rings B represent dynamics and diamagnetic particles. And Hedman and Nicholson, in their paper in Icarus in 2016, discovered optical illusion in the massive ring B, making astronomers think that it contains up to 7 times more mass than it actually does. It is like, it looks like a dense fog with small particles above the lake in the morning. We see spokes, what we see as a spokes, it's a small diamagnetic particles coming to the anomalies of the Saturn's magnetic field. Then, because of anomaly, because the magnetic field is changes, they change their position. They are mixing each other. And then, after passing magnetic anomalies, they're coming back to the stable position on the orbit. So, as it follows from our theory, smaller ice particles are affected strongly by diamagnetic force of expulsion. So, we have two confirmations. First of all, spokes confirms that existence of spoke confirms that our theory is working. And on another side, it confirms that particles have diamagnetism. So Cassini discovered, as we mentioned already, particles of rings have 93% of ice. In science of ice are known 17 types of ice on the Earth. We can choose modest appropriate ice on the Earth to discuss ice in the particles of rings. So on this picture, we can see presented by Professor Hamley from University of Illinois, published in 2000 in Annual Review Physical Chemistry. We can see the picture. This is a temperature and this is a pressure. We can see under the small pressure existence of the ice 11. Ice 11 is a diamagnetic matter, and it's a stable below 73 Kelvin, which is appropriate to the consideration for Saturn's ice. So it may originate of ordinary ice on the Earth below minus 32.8 in Fahrenheit, as scientists saying, and it's necessary to hold it for the 100 years in order to get this structure. So it was found in Antarctic, and it was the ice which was found in Antarctic has 100 years old. So ice 11 has orthorhombic lattice with ordered arrangements of protons. Cassini discovered spectral anomaly of thermal radiation of rings at submillimeter wavelengths. So it may give us ideas about physics of the particles of rings. So we can see over here on the picture, there is a role of the brightness temperature of the rings. And as by the way, it's happened with each rings, with A, B, and C ringlets. So it means it's saying that all ice in the particles have the same nature. So its paper was published by Linda Spilker and her team, and it's a very interesting feature. We try to discuss it and explain. We try to explain this also. Before that, we have to tell a little bit about the water, and water is the origin for the ice. So as a result of Physics Aqueous Solutions conference in December 15 this year in Moscow, the conclusion about water is that water is a complex chemical system. What we can call water is actually an aqueous solution. Chemistry saying the water is a liquid cannot be represented by a single set of identical H2O molecules. It is a complex system of different molecules, ion associates and associates. And aqueous solution is non-equilibrium system, and its properties can change over the course of an experiment. The solution changes if the process of water dilution itself occurs under any external influence on a solution. For instance, like magnetic field induction, what we have with the ice particle of the Saturn. And also depends on mixing, also what we have during the movements of the magnetic field particles. So, and moreover, fact is that for sudden shaking solution, it change property of solution of water. So certainly ice, which is in the Saturn rings, is quite different from the ice on the Earth, even by the features of growing, because it was growing in free space, and then it was growing for billions of years. So those arguments raise doubts about preparing a sample of ice in the Earth laboratory for study, which will be the same as ice in the particles of Saturn's rings in space at all, and in space at all. At the same time, we can talk about possible explanation of roll-off in Saturn ring spectra uh, based on our research, which been done earlier. All models are based on collective quantum dynamic phenomena that combine various demonstrations of superconductivity and tunneling protons in a proton-ordered crystal lattice of ice 11. Idea of superconductivity as a hypothetical idea was of rings particles was presented by Chorny, Kapranov, Chensky, and Pospelov in some publications in journal, astrophysical journal, then Astrophysics and Space Science, and IEEE Geoscience and Remote Sensing, and others. And another idea is related to excitation of proton ring current in ice 11, which do not experience electrical resistance, was presented in the paper by Yan, Gao, Liu, and Berli. It's a team of Chinese scientists and Oxford. They published paper in Archive in 2016. And moreover, the spectral range in the region where we have roll-off of the spectra of the rings, it was discussed in the paper presented by Japanese scientist Aiba and Shigenari in Journal of Chemical Physics in 2011, contains modes of intermolecular translational vibrations in water and in ice. So it means that we have deformations of hydrogen bonds. The concerted tunneling of protons, creating proton rings current in the ice 11, is expected to be excited by the same energies. And this is manifested in the anomalous drop of the radio frequency brightness of the rings in the submillimeter range. So in fact, what do we have? We have shown that magnetic anisotropic accretion can contribute to the Saturn rings origin when diamagnetic particles of the rings protoplanetary cloud started interact with the Saturn's magnetic field after its appearance. It means that the age of rings may be close to the age of Saturn magnetic field. So at the same time, we have to make important note. We didn't make any decomposition of existing knowledge about rings in any theories which been published before. We just added a new one, theory of magnetic anisotropic accretion, which is influence of magnetic field to the Saturn rings origin due to the interaction of the magnetic field of Saturn with the diamagnetic particles. From that point, we can say that Saturn created his rings by own magnetic fields. And any other famous phenomena, such as gravity defragmentation, gravitational resonances, dusty plasma, fluid dynamics, magnetic hydrodynamics, and others, all of them can contribute some features to the final picture of the rings. There is an intriguing similarity of pictures. On the left side on this slide, we can see, on the left side, we can see iron fillings around magnet bar. And on the right side, we can see Saturn surrounded by the rings. So for the left picture, the iron particles, they are sticking together. On the right picture, ice particles not stick together because they expel the magnetic field and they repel each other. So at the same time, we can say that there is a common physics in both cases because both phenomena are a result of interaction of magnetic field or magnetized particles with the presence of the field of gravity. So we have a key references, and it's some papers, it's an astrophysical journal, and some presentation at the 52nd annual meeting of the American Astronomical Society for Planetary Sciences this year in October. Then we have another presentation at the meeting of 235 American Astronomical Society in Honolulu in January this year. And also we have presented here some papers where we did some modeling of different ideas which been published earlier. And then also useful to look into the interview which been taken by well-known astrophysicist Frank Timis as a American Astronomical Society Journal Author Theories, and also 4 minutes popular movie related to the paper published by Cherny Kapranov this year in May. But before that, we published a paper, the same paper in Archive, July 8 of 2019. And shortly after this, someone on the West published movie saying that this idea of contribution of the magnetic field might be interesting during the study of exoplanets. So what I can say, thank you for your time and interest. Also, what I want to say that I wish to everybody in this year to live, love, to be in love, and to be happy. And thank you very much for your attention. Bye-bye.